Good morning, students. What about last day's class? Did you understand that? Is it clear or not? Did you watch it? If you are watching now and then, you will understand. Otherwise, it's not able to understand it. Am I correct? Okay. Then I think some of you are having some doubt about this configuration of copper and chromium. Am I correct? Okay, I will explain once again that. See, listen all of you. Then for chromium, actually it has to come 3D4 for us 2. But if it is 3D5 for us 1, both the D subshell and S subshell is having half filled configuration. So that is the reason only half filled and completely filled shells are more stable. Am I correct? That's why it has got the special configuration 3D5 for S1. Is it clear? Then shall we go to the copper? You know, it's actually it has to come 3D9 and 4s2. Yes. Okay. Then if it is 3D10, it is fully filled. And the 4s is 1. 4s is having 1. That means it is half filled. So half filled and completely filled shells are more stable. You know that. So that's why it becomes 3D10 and 4s1. That is the only reason why the chromium and copper is having special configuration to attain stability. Am I right? Okay. Then we can go to our topic, that is about blocks. You know that how many blocks are there? 4 blocks. Yes. Okay. Then these 4 blocks are S, P, D and F. See this one. This periodic table is classified into 4. That is, this one is S, this one is D, this one is P and this one is F block. Am I correct or not? Yes. Okay, you have learned already it. Then considering this S block, it consists of, you know, what are the groups? It consists of first group and second group, isn't it? Then first group. Okay, listen, first group elements. So which are the ones first group? Can you say? Which are the groups or which are the elements in the first group? These first group elements are hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Is it clear? Then see this electronic configuration also. Then for hydrogen it is 1s1. For then lithium it is 2s1, 3s1, 4s1, 5s1, 6s1, 7s1, like that it is going on. For all the elements there is a special configuration. Is it clear or not? You can identify that it. That is, if it is in the first shell or in the first period, it has got 1s1. If it is second shell or second period, it is 2s1. Then if it is in the 7th period, it is 7s1. Accordingly, the elements are arranged. Because of this particular configuration, that means we can say generally it is ns1. So it has got the outer configuration ns1. If the number of shell is 1, it has got 1s1. If the number of shell is 5, it has got 5s1. So that means it depends upon the number of shells. That's why we can say that the group number for S block is equal to number of electrons in the outermost shell. Is it clear? How can we find out the group number for S block? We can say that group number for S block is equal to number of electrons in the outermost shell. If the number of electron is 1, it has got a first group. That is, for all the first group elements, there is 1 electron in the outermost shell, that is S subshell. Is it clear or not? You have to write this one in your notebook already, I think. Then this one, this NS1 configuration. That means I will write only the outer configuration only. The inner there are electrons. Is it clear? So I have written only the outer configuration. Then consider the second group. It is also belong to this S block. So second group, helium, magnesium, calcium, strontium, barium are the second group elements. See this electronic configuration, all are having 2 electrons in its outermost shell. That is, for helium it is 2s2, then next one 3s2, 4s2, 5s2, 6s2, 7s2, like that it is going on. For we can say that it is having a general configuration NS2. NS2, that means all the elements are having S2 configuration in its second group. That means group number for S block is equal to number of electrons in the outermost shell. For the second group, it is also like that, 2 electrons in the outermost shell. So group number, so particularly we can say that the group number for S block is equal to number of electrons in the outermost shell. Is it clear or not? Then we have to consider about the P block, D block and F block. Now we can go to the next part, that is the characteristics of S block elements. So what are the main characteristics? You know that they are in the left hand side of the periodic table. So that's why they are a metallic character. They are showing the metallic character. Is it clear? Then you know that they are having 1 electron or 2 electrons in their outermost shell. That means they can donate electrons. The next one is they can donate electrons. Am I correct? Okay. The next one is they are having less electron negativity. You know, you have learned last year the electron negativity definition. The capacity of each atom to attract the bonded electron pair towards it. That means they are having less electronegative character. They are having the electropositive character. Then they are forming ionic bond. That's why you can say that ionic bond is formed by the transfer of electrons. They are having either 1 electron or 2 electrons. So we can say that they donate electron and form ionic bond. Is it clear? So we can say that these are the characteristics of S block elements. So we can conclude this, and I'll give you one homework for you. What is the homework? You have to write the electronic configuration of S block elements as homework. Is it clear? Okay, thank you.